Okay. Welcome. This is Understanding Linear Inequalities in Depth. It's an in-depth exploration of linear inequalities and their applications. This is also my first video of the year. Very first video of the year. So, defining linear inequalities. Linear inequalities are mathematical statements that express a relationship between two expressions using inequality symbols such as less than, less than or equal to, and greater than or equal to. For example, the inequality 2x plus 3 is less than 7 indicates that the expression 2x plus 3 is less than 7. Solve linear inequalities. One often rearranges the terms to isolate the variable, while maintaining the direction of the inequality. For instance, to solve for x, inequality 2x plus 3 is less than 7. Subtract 3 from both sides to obtain 2x is less than 4, and then divide by 2 to get x is less than 2. Transitioning into key concepts. Now that we understand the definition, let's explore the properties and graphical representations of linear. Left column content. Linear inequalities maintain certain properties similar to regular equations. For instance, when you add or subtract the same number from both sides, the inequality remains valid. An example is if the inequality. An example is that if we have x plus 3 is less than 5, subtracting 3 gives x is less than 2, which is valid. However, one must be cautious when multiplying or dividing by a negative number, as this reverses the inequality. For example, multiplying -1 both sides of it, -2x is greater than 4, leads us to 2x is less than -4, reversing the inequality sign. Hence, these properties are essential for proficient way solving and manipulating inequalities. So single variable inequalities involve one variable such as x is greater than 3 or x is less than equal to -1. Multivariable inequalities include two variables and represent them geographically in a coordinate plane, like y is less than 2x plus 1. So compound inequalities go by multiple inequalities. For example, 1 is less than x is less than 5, which dictates a range of for x. So to effectively solve inequalities, construct a logical methodology to reach a solution. Begin by isolating the variable, followed by assessing any operations on both sides. So, identify the inequality in the variable to solve for. Perform allowed arithmetic operations uniformly to isolate variables. Re-evaluate the inequality. Reversing signs of multiplying, dividing negatives. Express solution in an interval notation is set of a notation. As applicable. Graphically represent the solution on number line. So graphing linear inequalities entails plotting the related linear equation first, shading the appropriate region to indicate solutions. For example, for the inequality y is less than 2x, less than or equal to 2x plus 1. One graphs the line y equals 2x plus 1 as a solid line since the inequality includes equality. So, one thing now I want to point out. So y equals 2x plus 1 is written in slope-intercept form. So, linear inequalities are used intensively in various fields such as economics, engineering, and environmental science. For instance, businesses utilize them to define constraints in resource allocation, with formulas indicating product production limits. So, here's a real world example. So, in economics, consider a factory that could produce almost 300 units of widgets in 1 week due to labor and material limits. The inequality representing this solution is x is less than or equal to 300, where x stands for the number of widgets produced. Okay. Okay. Where x stands for the number of widgets produced. And the factory sells each widget at a profit of 5, the maximum profit. Can be expressed as p equals 5x. And thus the profit inequality can be written as p is less than or equal to 1500, affecting the balance set by a production limit. This simple model illustrates the foundational use of linear inequalities in resource management. So, here's a key insight. The beauty of linear inequalities lies in the ability to delineate feasible religions within mathematical modeling. By expressing conditions sufficiently, they empower precise decision making across sectors, highlighting their importance. So here's the common mistakes. So, many learners struggle with linear inequalities, including me sometimes, particularly regarding sign changes when dealing with negative numbers. Common mistakes include failing to reverse inequality signs or misinterpreting the graphical representation. So misunderstanding sign reversal and multiplying negatives. So, um, people struggle to do that. Oh, sorry. Oh, God. Sorry. Okay. Um, so, here is how I would do this. So, I have this inequality. Negative 2x is less than or equal to 6. I divide that by negative 2. And I have x is less than or equal to negative 3. So, graphical errors in shading regions. Don't do that. So, neglecting to express solutions correctly in notation. Underestimating the impact of compound inequalities. Don't do this. So, skipping verification steps to ensure accuracy. Yeah, we need accuracy when it comes to um, inequalities. So linear inequalities are pivotal in mathematics, governing expressions with constraints. They provide essential tools for modeling real-world scenarios from economics to engineering and help inform decision making. Additionally, grasping the properties of linear inequalities is crucial for successful manipulations and practical application. So, here are the 5 basic steps that I want you to follow. Revisit basic definitions and properties of inequalities. If you have done that, check. Engage in varied practice problems to enhance skills. If you have done that, check. Explore applications from real-life situations to deepen understanding. If you have done that, check. Collaborate with peers for diverse perspectives. I sometimes do it too. Seek additional resources or tutoring for complex topics. If you have done that, check. Thanks. Thanks for your attention. So, we appreciate your participation in this exploration of lunar inequalities. Questions are welcome. So, make sure that you learn all the types of inequalities.